feasibility report on solar panel technology, as well as CPU efficiency advancements for Daryl's web design, created by Ryan Brewski. Most people already know what a solar panel power system is. It's a system that utilizes light from the sun to convert into energy to then be used in residential or commercial settings. Now, solar panel power is the most cost-effective energy source. So when we compare it to other common sources of energy, such as coal, fossil fuels, or hydroelectric generation, it costs the least amount per watt of power generated. It is economically and ecologically viable. I just said it's cost-effective, and it has no negative environmental effects, such as we see with coal, fossil fuel, or oil. It's benefited from over a 60% cost reduction in the last decade, partially due to advancements in technology, and partially due to programs set up by the United States government to incentivize solar panel power systems. They are durable and designed for long-term use. The average life expectancy of a solar panel system is about 20 years. Now, if we look at CPU efficiency trends since year 2000, we see that every year it is inclined greatly. This is partially due to an increased demand for network resources, as well as an increase in the amount of traffic we see in the web. So with older CPUs, they're not efficient and they're using way more energy than we need to use compared to current models of CPUs available. So after inspecting Daryl's web design server site, I was able to come up with a few appropriate recommendations based on what I saw there. First thing I noticed was that the CPUs were very outdated and not operating efficiently. They would definitely benefit from the upgrading of the CPUs to a more efficient model. Pair this with a 20% rise in the cost of electricity in the 10 years for Daryl's web designs area, and you've got quite a concern for the utility bills that it's going to generate. I also noticed that the premise was ideal for a solar panel installation. The roof was clear of obstructions. We had access to the roof. There was no high-rise buildings or trees in the area to obstruct the sunlight that could be absorbed by the solar panels. And the roof was structurally sound. There was no concerns with the integrity of the roof. So based upon this, we came up with this graph of what the CPUs are currently costing Daryl's web design to run. Now they have 2 server racks with 3 servers in each rack, meaning we've got a total of 6 servers operating. There's 1 CPU in each one of these servers, and each one of these CPUs is consuming approximately 2.3 kilowatts of power per hour. So, if we look at the total annual cost using these figures, it's costing Daryl about $9,320.65 to keep these servers operating. That's quite an expensive bill. So, proposal phase 1 is going to deal with the upgrading of the CPUs. If we upgrade the CPUs to the Intel Xeon E5 2630, we're going to be reducing that power consumption figure by about 65%. Now, because we're upgrading the CPUs, we're also going to need to upgrade the cooling fans associated with those CPUs. The Dell 6D1 GT cooling fan will be compatible with the CPU and will meet the cooling requirements that we need. So, if we look at the costs of upgrading the CPUs and the fans, we have 6 CPUs total that need to be upgraded at a cost of $676 each. This means it's going to cost about $4,056 to upgrade the CPUs. Then we need to upgrade 6 fans. Each fan is going to cost about $175. This brings our total cost to about $1,050 for the fans. If we combine these, we arrive at the total cost for this upgrade of $5,106. Now, if we look at the annual cost savings of what this upgrade could bring us, it's going to reduce our power consumption by about 65%. So when we play that out, that looks at savings of about $6,058.20 annually. So this project, the upgrade costs are going to be covered by the potential savings within the first year alone. Now if we look at phase 2 of our proposals, it's installing a rooftop solar panel system. Combining this with phase 1 is going to provide us maximum cost effectiveness. By upgrading the CPUs, we're going to reduce the power consumption level of the server site by 65%, meaning the solar panel system that we have to implement will be much smaller than if we didn't upgrade the CPUs. We're going to use a grid tie-in method, which means that we'll still be connected to local power grid, so that if we have a prolonged outage of our solar panel systems or other concerns like that, we will still have power available to resume operations as normal. We also will still utilize the diesel generator backups that are already in place for Daryl's web design in case of a total power failure by the power company. If we look at the cost analysis of the proposal phase 2, we're going to require a solar panel system that can generate 5 kilowatts of power each hour. The approximate cost for equipment and installation of a system of that size is about $15,500. Now, the ITC offers a tax credit of 30% that the business owner can claim on the next year's taxes. This brings the net cost after that credit to $10,850. The really great thing about this phase is that it's going to reduce the annual utility bill to 0. Now, combining phase 1 and phase 2, like I said, is our maximum cost effectiveness. The total cost between the two proposals is about $15,596. That's after we figure that 30% ITC tax credit in there. It's going to present us an annual savings of $9,320.65, which, if you remember, was the total annual cost to operate the servers every year. If we run this into a 10-year net savings, which is the annual savings multiplied across 10 years minus the initial cost of the project, we come out to a net savings in 10 years of about $77,610.50. There are virtually no drawbacks to this. You'll still have the same redundancy and reliability provided to you by the current system in place, and there's not going to be any negative ecological side effects. There's not going to be any wildlife harm. There's not going to be any negative waste products or byproducts of the system. So the conclusion of the cost analysis and proposals is that time is of the essence. The ITC tax credit, construction must be initiated by the end of 2019 in order to be eligible for the ITC tax credit. Remember, that reimburses you 30% of the cost of the solar panel installation. The proposals would also provide long-term sustainability for your business. They're going to give you 10 years of reduced utility costs, allowing your business to thrive on other potential areas. The system would be expandable. We're only going to implement the solar panel system at the server site currently. If Daryl's Web Design decides that this is a beneficial move and that they like it, they can always choose to implement it in their employee operations centers where they employ web designers, web developers, and other technicians. This is a mutually beneficial cost reduction for the business, the environment, as well as the employees. As I said before, there are no negative environmental effects brought about by solar panel power systems. It's going to save Daryl's Web Design nearly $9,500 every year, and it's not going to place any burden on the employees. It's not going to make them have to do any extra work, and it's not going to affect any employee satisfaction level. So this has been my feasibility report on CPU efficiency upgrades as well as the implementation of a solar panel power system.